This is our fourth video for Chapter 1. This is Chapter 1, Section 4, Fractions and Decimals. What you'll learn in this video is to convert between fractions and decimals and back again. And remember, the result of dividing a dividend by a divisor is called a quotient. So a division answer is a quotient. You have two terms to define in this video. They are terminating decimal and repeating decimal. When you see them in the video, please pause the video and write their definition in your notebook in your vocabulary or terms section. Now, you write a fraction as a decimal by dividing the numerator by the denominator. If the decimal stops or terminates, it's a terminating decimal. So again, if you're looking at a fraction like 1/2, the numerator, which is the top number, is divided by the denominator, which is the bottom number. So that means the top number's on the inside and the bottom number's on the outside. Now let's look at an example of writing a terminating decimal. The pull of gravity is weaker on the moon than on the earth. The fraction 4/25 represents the ratio of the moon's gravity to Earth's gravity. We're going to use long division to write this fraction as a decimal. So if I'm turning my fraction into a decimal, my top number is going to be on the inside, my bottom number is going to be on the outside. So 4/25 is the same as 4 divided by 25, which is the same as 25 on the outside and 4 on the inside. Now 25 can't go into 4, so I have to add a decimal and add a 0. So now I'm looking at 25 into 40. 25 only goes into 40 once, then I'm going to multiply down and subtract. So 40 minus 25 is 15. Then I'm going to drop another 0 because I can't do 25 into 15, so it gives me 150. 25 goes into 156 times, multiply down and subtract. So the remainder is 0. Once you get a remainder of 0, your decimal has terminated. So the decimal of the fraction 4/25 is 0.16. So the ratio of the moon's gravity to Earth's gravity is a decimal of 0.16. This is a terminating decimal because the division process stops when the remainder is 0. If you continue to divide, the rest of the digits in the quotient will all be zeros. Pause the video and do this quick check in your notebook. Be sure to label it as quick checks or exercises. Write down the original equation and show any and all work. Now, if the same block of digits in a decimal repeats without ever stopping, the decimal is a repeating decimal. The repeating block can include one digit or more than one digit, but it's the same block of numbers repeats over and over again. So for 5.3555555, you would write that as 5.35 with a bar over the 5 at the end because that is the number that repeats. Now for 0.1717171717, the digits that repeat are 17. So when you write it, it's 0.17 and the bar is over both the 1 and the 7 because both of those numbers repeat. So if you had 0.6925669256, you would write that as 0.69256 and have your repeating bar over all of those numbers because all of those numbers are in the repeating block. Let's look at an example of coming up with a repeating decimal. So we're going to again use long division to figure out 3/11 as a decimal. So 3/11 is the same as 3 divided by 11, and we know the bottom number or the second number is on the outside and the top number or the first number is on the inside. So if we're looking at 11 into 3, 11 obviously can't go into 3, so we need to add a 0. So 11 goes into 30 2 times. So then we multiply down. 2 times 11 is 22. Subtract out. Gives me 8. Bring down another 0 because I can't do 11 into 8. So now I'm doing 11 into 80. 11 goes into 80. 7 times, multiply down and subtract. 80 minus 77 is 3. Bring down another 0, or add a 0 and bring it down. So now I'm looking 11 into 30. 11 goes into 30 2 times, multiply down. Same answer as up here. So that lets me know that this is probably going to be a repeating decimal. So that again gives me 8. I drop another 0 to make it 80 instead of 8. Then again, 7 times 11 gives me 88, or 80, I'm sorry, 77, wow. Then subtract out, leaves me with 3 again. So I know that there's always going to be a remainder of 30 or 8. So my repeating decimal is the 27. So if I'm going to write this as a repeating decimal, it's going to be 0.27 with the repeating bar over both the 2 and the 7. Pause the video and do this quick check in your notebook. Now, you can write a terminating decimal as a fraction or a mixed number by writing the digits to the right of the decimal point as a fraction. So if we want to write 1.325 as a mixed number with a fraction in simplest form. So before we were going from fraction to decimal, now we're going from decimal to fraction. Now I have 1.325. And I know if I have a whole number before the decimal, that means I have a whole number. So I can go ahead and write my whole number. Then to make 0.325 into a decimal, you look and see, okay, the last number is a 5. The 5 is in the tens, hundreds, thousandths place. So to turn that into a decimal, I simply take that number, put it on the top, and then put the value of the decimal place on the bottom. So 325 thousandths becomes 325 over 1,000. So then we would take it, that would become 1 and 325 over 1,000, because that's going back to my original number of 1.325. Now, 325 and 1,000 are going to have things in common. They can both be divided by 25. Which is going to be the greatest common factor for these two numbers. So 325 divided by 25 and 1,000 divided by 25 leave me with 1 and 13/40, because 325 divided by 25 is 13 and 1,000 divided by 25 is 40. So my decimal written as a fraction in simplest form is 1 and 13 over 40, or 1 and 13/40. Pause the video and do these 3 in your notebook. Be sure to show me how you figured it out and write down the original number. Now, to compare fractions and decimals, you can write the decimals as fractions or write the fractions as decimals, whichever one you prefer or whichever one seems the easiest. But they all need to be changed to the same thing. Either everybody needs to be a decimal or everybody needs to be a fraction before you start putting them in order. So let's look at the example. We want to order from greatest to least to 2.55 and 2 and 16/18. So I want to change 2 and 6/18 to a decimal, because 2 is already a whole number and 2.5 is already a decimal. So I don't want to have to change those two fractions. Plus 2 and 55 hundredths is just an ugly fraction. I don't want to deal with that. So I'm going to go to decimals. So 2 and 6/18 will simplify down to 2 and 1/3. And I know just from learning math that 1/3, the decimal for 1/3 is 0.3 repeating. So 2 and 1/3 is 2.3 repeating. So then when I put those in order on my number line, 2 will go first, then 2.3, because 0.3 is less than 0.5, and then 2.55 would be last. So when you actually go to put these in order, you need to put everybody back in their original form and put them in order. So the numbers in order from greatest to least would be 2.55, then 2 6/18, and then 2. Here are some common equivalents, so fraction to decimal to percent. These are ones you will see a lot in this chapter and as well in your math career. So it's worthwhile to try to memorize them as much as you can. Go ahead and please copy these charts into your notebook. I know it's a lot of numbers, but it will be worthwhile in the end because it will be stuff that you do not have to work out later because you already know the answer. Pause the video and do this quick check in your notebook. Remember, you're ordering from greatest to least. You can also order rational numbers. Use ordering rational numbers to analyze data results. So say we took a survey, and as for a survey, adults were asked to choose one animal from a list of 4 that they thought was the most endangered species. Of the adults surveyed, 0.25 chose black rhinos, 10 of 48 chose the tiger, 5 of 12 chose the giant panda, and 0.125 chose the mako shark. So we want to list their choices in order of frequency. So first we're going to write all 4 of the ratios as decimals. So the black rhino is already a decimal, so that's 0.25. The tiger we have to convert. 10 over 48 will simplify down into 5 over 24. Then you just have to do the long division, and that works out to 0.2083 with the 3 repeating. The giant panda, 5 divided by 12, gives us 0.416 with the 6 repeating. And then the mako shark is already a decimal at 0.125. So if we look at these values, we can now easily compare them by first looking at the number in the tens place. So the order of frequency, we're going to start with the one that happens the most often and go to the order of the least often. So 4/10 is bigger than all the other ones, so 0.416 repeating. Next we look at the 2 that have a 2 in tenths place. So there's 0.25 and 0.20, so 0.25 is bigger than 0.20. So the black rhinos at 0.25 is our next number, followed by the next one with 0.2 for the tiger, and last is the mako shark, in their opinion. So the frequency was giant panda, black rhinos, tiger, and mako shark. Pause the video and do this quick check in your notebook. Again, you are ordering from greatest to least. The ones they want the most to the ones they want the least. Now let's check your understanding. Be sure to label it as check your understanding in your notebook, number all the problems, write down any equations that are you given or that you create, and show any and all work. Enjoy the rest of your day, and I'll see you tomorrow.